Hello and welcome to this video presentation on the GLOBEClaritas Image Suite application. This is our new seismic processing toolkit of high-performance processing algorithms. The aims of the image application are to deliver class-leading processing solutions to both the GLOBEClaritas and wider seismic processing community. This is provided by a simple, easy-to-use GUI interface and by the use of standard industry data formats such as Segway Revision 1 to deliver both seismic and velocity datasets to and from the application. Parameterization of the application uses either robust and sensible defaults or is automated to limit the possibility for user error resulting in an incorrect result. If you have installed the image suite as a standalone application, you can start the GUI by typing claritas_image_UI in an X terminal window. If you are a current Claritas user, you can start the image suite standalone by clicking on the image suite button on the flow tabs of the Claritas launcher. As you can see, when the application launches, there are 4 tabs displayed across the top, one for each of the different algorithms currently available. These are our 5D interpolation algorithm, Stitch, a 3D SRME multiple modeling algorithm, isotropic and anisotropic 3D pre-stacked time migration, image K3T, and our new broadband solution, Octave. Other functionality available from the image suite application includes a simple drop-down logging window, which the user can leave open or closed. The arrows that open and close the logging window will turn red if closed and an error is encountered. You can also access the Claritas License Manager application, which we can use to import a license key or point to a license server. For the purpose of this video, we'll use the image K3T application to demonstrate the image suite's functionality. First, we need to select an input data set. On the K3T tab, click the Edit button next to the Scan function. This will show a simple single parameter pane with an Add File button. Until a file has been selected, both the Edit and Add File buttons will show a warning triangle. Click on the Add File button and the operating system standard file selection widget will open. From this you can navigate to and select your input dataset. Datasets can be removed by highlighting the file with the left mouse button and using the right mouse button to select Remove. You will notice that once a file has been selected, the warning trials disappear and the Scan button is activated. Click on the Scan button to scan the input dataset. This process confirms that the dataset is an acceptable format, Segway Revision 1 or Claritas Segway format, builds a suitable 3D grid definition file, and populates parameters in the parameter form of the image K3T application. As the scanning application runs, information is displayed in the logging window, and the progress bar provides user feedback on status. Once the scan application has completed its work, click on the K3T Edit button. You will see that as well as the geometry parameter having a 3D grid file specified, the first, last, inline crossline and min-max offset parameters have been populated with information extracted from the trace header of the input dataset. Click on the Velocity button to select an input velocity field. This can be Segway Revision 1 or Claritas NMO format. If you want to run anisotropic pre-SDM, select an ETA field by clicking on the ETA button. Populate the output file parameter with a suitable path and file name for your output dataset. Applications in the image suite can be run interactively by selecting Run Locally or Batch if a suitable queuing system is detected and submitted to the identified queues. For this test, we shall also restrict the inline crossline range, allowing the process to run faster. The parameters can be updated either using the up-down arrows or by typing the desired values into the parameter box. Warning triangles will appear and the application will be disabled if parameters are incorrectly set. The example data file we are using is a single offset plane, so we shall set the offset file parameter to 1 from its default of 60. As K3T and Stitch can both run on single fold common offset and shot or CDB gathers, the user can define the desired output fold. The offset increment parameter is automatically calculated by dividing the max offset minus the min offset by the user specified fold. The simple up-down arrows can be used to update the migration parameters, or the user can choose to click in the parameter box and manually enter the desired value. We can also define a header into which the minimum migration distance can be written. We can then select the number of cores we wish to use. If using multiple compute nodes, define how many cores to read the data, and then click on the K3T button to run the application. When the application starts, the Run button and parameter form are disabled. The initial phase of the application will read and bin the data, identifying traces to use in the process, and this information will be printed out in the logging window. The progress bar will keep the user informed as to the application status. Once binned, in this case, the migration will start, and again, the progress bar and logging window will keep the user informed as to the status of the process. Once the algorithm has finished processing, the resulting segy revision 1 or csegy dataset can be read into your preferred processing package for QC and ongoing processing. Thank you for watching, and if you would like to know more about the image suite or to evaluate the application, please contact claritas.sales@gns.cri.nz.